Now, in continuation to where I actually stopped, so recall that question number one, we actually arrive at two answers, which are p equals to 5 and p equals to minus 27. So these are the two solutions that you can actually have. If these are the two solutions for p, for which they cover as a stationary point on x-axis. So you pick option D as the correct answer to this. Now let's move straight to the next question. Question number two says integrate x squared minus x minus 1 dx. Whatever you have to do here is to just find a way to bring out x minus 1 from this upper part. And we all believe that this can be easily done by saying just put minus 1 plus 1. By the time you introduce minus 1 plus 1, it's still setting as x squared. And here in this case, you have x minus 1 down here. Looking at this, what if I take this together? Then you'll believe that difference of two squares will come out from this. Okay, then you have plus 1 left. Now you all believe that if you have something like Sikira plus Shaki over 2, mathematically speaking, that's a Sikira over 2 plus Shaki over 2. You do the same thing here. If this is Sikira and if this is Shaki, you know what to do from there. And that will be x squared minus 1 over x minus 1 plus you also have 1 over what? X minus 1 in that case. All into what? Dx. Okay, is that clear? Now, here in this case now, this is difference of two squares. X squared minus 1. And x squared minus 1 implies you have x minus 1 and you have what? X plus 1. And in this case also you have 1 over what? X minus 1 all into dx. Now, trivially, this cancel this. Whatever I have left now is just x plus 1. So I want to split up these integrals now. I have x plus 1 left with what? With this dx. And I have to integrate 1 over x minus 1 dx also. So trivially, if I integrate x, I have x squared over 2. If I integrate 1 dx, I have x. I believe you know how to do that. Integrate 1. Integrate 1 dx. That's x is power of 0 dx. By the time you add 1 to that power, 0 plus 1 over 0 plus 1, you have x is power of 1 over 1. And that's x. That's very direct. And here in this case, whenever you want to integrate 1 over x minus 1, just like saying integrate 1 over x, and that's what? Ln x. That is, you have to differentiate this thing first. Differentiate x, that's 1. That 1 will now multiply ln of whatever you have here. So the same thing goes with what we actually have here. In this case now, this is just differentiate this x minus 1. And that's what? That's just 1. Right? 1 times ln of what? What do you have here? X minus 1. Then plus constant k or plus constant c. So trivially, I have my answer as option B. X squared over 2 plus x, then plus ln x minus 1 plus constant what? C. So that's how it works. Please take note of that. Next question. Question number 3, which says integrate 5x squared plus 6 over x squared plus 1 dx. You have to just manipulate it. Just think of what to do. In this case now, if I have 5x squared and I have plus 6, whatever I have to just think of is how can I break down this 6 such that I will end up having x squared plus 1 as a common factor. So that means just split it up as saying you have plus 5 plus 1. That's the best thing to do, so that when you take these two terms, 5 is common, then you have x squared plus 1 showing up. You see, it's just based on, just think of what to do. Nobody will tell you what to do in that case. So in this case now, 5 is common, then you have x squared plus 1 just for these two terms, right? You have x squared plus 1 down here, and then finally you are left with 1, x squared plus 1 dx. I repeat, what I actually did was I picked these two terms, see it here. 5 is common, you have x squared plus 1, then plus this one that you actually have here. Now in this case now, this cancels this, I have integrate 5 plus, all this one is in dx, so okay, then integrate 5 plus, let me just put dx straight up here, and integrate 1 over x squared plus 1 dx. So in this case now, if I integrate 5 dx, that's 5x. And we all believe that the integral of 1 over 1 plus x squared, this is standard integral that you must know. This is always equals to, whenever you want to integrate something like this, you all believe that that's tan inverse of x. Please take note of that. So if I integrate this guy here, I have tan inverse of x, then plus constant c. That's option what? Option B is absolutely correct.